In the previous video, we have seen how GraphQL works. If you haven't seen that video, please go and watch that video so that you will have a better understanding of how GraphQL works. This is a simple Java application. It's not a web application. It's just to show how GraphQL functions work and how this object bundling happens. In the form file, I have added one dependency, that is com.graphql java. No other dependencies are added here. This class, consider it as a client. It will read the query from the class path, the resources client. This is the query. We can add all the queries what we want. It's just mocking the client and API situation where this is the client and it will call the server, which is query test main. Let us see query test main. This is the query test main. Before that, let us see our schema as well. In the server side, we need a schema, right? Schema file. In the schema file, we have query. In that, three queries are there. One with field company, and it has an argument ID. It returns company object. Then company list, it doesn't have any argument. It will send or return a list of companies. Then the branch, it will have an argument branch ID. That means from the client we have to send branch ID. Then it will return branch according to that ID. Then we will see how mutation works with create company. It will take one input. That means one argument will be the company input, and it will return a list of companies. All these objects, company object, branch object, and the company inputs are defined here. So if you are defining an object anywhere in the query or mutation or subscription, that its type need to be defined in the schema. This schema is what GraphQL is going to use for defining what are the fields, what are the queries that client can send, all those details. Now let us look into what are the coding we have done in the server side. This is our server side. It is reading a schema file. These are plain Java code. Then a schema parser object is created. Then we are parsing the input file. It's converted into a string and we are parsing it and creating the type definition registry. That means it is registering to the type definition registry, the whole schema. Next one is the runtime wiring. Here what we are doing is we are defining what are the queries and what is the function which is going to resolve that query. Here the type is defined. We are saying that it is of type query, is the root operation type. That's what is defined here. In the builder, we are mentioning the data fetches. We have to define data fetches for each of the queries we defined here. We have company, company list, and branch. So you can see company, company list, and branch. Each one is having a data fetcher object. Let's see company by ID data fetcher object. When we create a data fetcher object, we need to override one function, that is the get function. This is the only function we are interested in. Any query from client side will get into this function. It provides us an environment variable, data fetching environment. All the arguments we can read from environment. Here you can see that environment.get argument, the ID, whatever the ID we have mentioned here, right? This name, exactly the same name we have to mention here to get the data value. Here what we are doing is we are getting the company from the data repository by using the ID. This data repository is a simple repository I created. It has some hard-coded values, company with ID 1, 2, 3, and 4, some branch objects with the IDs B underscore A, B, C, D, and E. This is just to simplify the process of, instead of going to database, we are just taking it from static objects. That's all. So company by ID df. Next one is branch by ID df. Is the same get function. There, what we do here is up to us. This is our business logic or our custom code. Only thing is, it need to return a branch object, and from the environment variable we will get a ID that you can use. Same thing for get company list df. And the next one is the add company df. There also the same get function. Here we'll get company input values. Then that we will be using it to create a company object and adding to the data repository .company.put. It's a new company object we added to the data repository. That means it's like you are inserting a record into database. If it is there, we are updating. If it's not there, we are inserting it. Here you can see that it is returning a collection of companies. That means all the companies is returning. So we'll see our new record also as part of the return value. These are the few steps we need to write if you're writing GraphQL code using pure Java. Let us run some queries. Here query also I put into a file so that we can change the query and run the code. The first query is company with ID equal to 1. This is the query that will be run at the server side. Let us run it. You can see the output here. In the output, we have mentioned what all the fields required: ID, name, building number, street, state, and country. All those informations are available here. Let us reduce the fields here and see what will be the output. We learned that GraphQL is used for querying the API output, right? Let us run it. Now you can see that only ID and name are there as the output. So what all fields we need, we can mention here. Suppose instead of saying ID, I want the output as ID with the uppercase. See the output. It got renamed to capital ID. That means field renaming also we can do here. Here it says that I want the output as capital ID. Its actual field name is ID. This is the field that will be combined with the company object here. Let us run a few more queries. Here you can get the company list. You can see all the companies are here. ID 1, 2, 3, and 4. Here also we can reduce the fields and execute. You can see the output here. It has ID, street, state, and country. Name is removed. Name and building numbers are removed. Let us get the branch. You can see the branch details. Now let us run the mutation. So these are the client requests we are sending, right? The mutation name is create company. In the schema also we mentioned mutation. The field name is create company. It has an input, company input. Company input has the values ID and company name. We are expecting the output are only ID and name from the list of companies. Let's execute it. Here the ID given is 7 and the company name is company name 7. Input is added into the repository. We can see here. This is the way the GraphQL works, and then with this Java example we can see what are the configurations needed for making the GraphQL work.